Hello, in this video we're going to look at the relationship between grams and moles and doing calculations involving grams and moles for a substance. This is going to apply for, the setup will apply and work for any type of atom, any type of element, or any type of compound. Obviously the difference though is going to be depending on what you have. You need to factor in the correct molar mass, which we can find on the periodic table. So just to review what we saw in the previous video is that we have the definition of a mole has to do with a certain number of atoms, and we know that Avogadro's number is that number of atoms that we associate with 1 mole of something. However, when we talked in class, we said, well, counting things is great, but really we need to be able to connect to something we can actually measure because atoms are way too numerous for us to actually count. And so we said there's a connection to the masses from the periodic table, and we showed that derivation in class for the relative mass from the periodic table in grams is equal to a mole of that particular element. So this particular problem, we're converting from moles to grams. So I need not Avogadro's number. So notice atoms doesn't appear anywhere in this problem. Instead of Avogadro's number, I need the other side of the mole definition, which relates then to that particular substance that you have the atoms of. So I know from the periodic table that there's a relative mass of 40.08 AMU, that's for 1 atom of calcium. But we said that those masses in the periodic table are, if we measure out that mass in grams, that relative mass in grams, that would then contain that Avogadro's number of atoms. Now again, for this particular calculation, I kind of don't care about the number of atoms, so I'm really just going to be sticking with this part of the mole definition. So it's going to be your job to know the mole definition, but when I'm converting just between mass and moles, like this problem and the next one, I just need to focus on the relationship between grams of that substance and moles, and that comes from the mass from the periodic table expressed in grams is equal to 1 mole. Hopefully you can see that with the glare on the video there. Okay, so these are the 2 units I'm relating between. I am going to start by writing down the number given in the problem, 2.45 moles, and then again setting up a conversion factor. And conversion factor always contains the 2 units that I'm interested in and their equivalents to one another. So for calcium, 40.0 grams is equal to 1 mole. So I want to end up with the grams. I'm going to put that 40.0 grams in the top, and I want the mole unit to cancel out. Notice the abbreviation for mole is just MOL, so you'll see me chopping it off periodically. That's the only way that's appropriate to abbreviate the mole, because with just the E chopped off, not just M or not just MO, it's MOL. So notice 2.45 times 40.0. Again, we're going to be limiting our significant figures just based on the original number. So this has 3 digits. Make this 3 digits, so 98.2, and then as a unit of grams, since it's left over on the top of my conversion factor that hasn't been canceled. And if you think about what this is saying is, well, 1 mole would have 40.08 grams, but I've got 2.45, so I have certainly more than the 40.08 grams because I have more than 1 mole, and so I'm just multiplying, and I get the 98.2 grams for the 2.45 moles. This next problem is for the reverse, the opposite, where I have grams given to me, and I want to find moles. And so to do that, well, I need the relationship between those 2 units for calcium. So 5.73 grams and moles are related by this relationship, 40.08 grams equals 1 mole. And I'm going to start by putting down the number given in the problem, and then set up my conversion factor. So if I'm doing the opposite conversion, so instead of going from moles to grams, like in the previous problem, I'm going from grams to moles, well, then my conversion factor is going to be flipped upside down because I want to end up with moles, so that unit is on the top. The 40.08 grams has that matching unit of my original number, so that goes on the bottom. So 5.73 divided by 40.08, and that gives me 0.143. And that is the moles of calcium. So there you go. So anytime I'm converting between mass and moles, and only mass and moles, I do not need Avogadro's number in any way, shape, or form. It was not needed. I didn't mention atoms at all, and so I would not be using Avogadro's number if atoms or molecules or whatever it is that you're counting is not mentioned. The other thing is that, again, this relationship between moles and grams, this is called molar mass. And so this mass comes from the periodic table for this element. And so it's that number from the table, the atomic mass from the table expressed in grams, that's equal to 1 mole. If I had a compound, so like if I had, calcium chloride, CaCl2 or something, then it would be, like we talked about for the mass of a compound, this mass would be all those masses added together, but expressed in grams, and that would be for 1 mole. And that's it.